given function f of z is 1 by z square minus 1 into dz. So C is the curve which is a circle here. Mod z is equal to 2, which is x square plus y square is equal to 4. So the radius is given as 2. You can represent it in the form of circle with the radius 2. This is 2 minus 2 2i minus 2i. So this is a circle. Our points are z minus 1 and z plus 1. Means there are two poles inside which are at 1 and minus 1. If this particular curve under consideration, if it covers all the poles, if it does not cover, then the value of integral of f of z dz is equal to 0. But if it covers, if it encompasses the poles present inside it, then we have a separate formula for it. It is given by 2 pi I into f of a, where a is the pole. So if we are considering z minus 1, which implies z is equal to 1 as a pole, now our f of z under consideration will be is equal to 1 by z plus 1. We'll write it as f of z by z minus 1 integral c dz, whose value will be 2 pi I into f of 1, where here f of z is 1 by z plus 1. So the value is 2 pi I into 1 by 1 plus 1 is equal to pi I. Similarly, if you are considering z plus 1 as a pole, the value of z is equal to minus 1. So our f of z will be is equal to 1 by z minus 1. Now we are writing the same function as f of z by z plus 1 dz, whose value will be 2 pi I into f of a, where a is here minus 1. So the value is 2 pi I into 1 by, here it is z minus 1. So here it is minus 1 is equal to 2 pi I into minus 1 by 2, whose value is minus pi I. Now the value of the total integral c f of z dz, where f of z is 1 by z square minus 1, will be addition of f of a1 plus f of a2, 2 pi I multiplied by 2 pi I. So we know the value of 2 pi I f of a1 is pi I and 2 pi I f of a2 is minus pi I. So the value will be equal to 0. So 0 is there in the option C.